Okay, here we go. So, we're okay with the graph, right? So the dotted line, again, is the asymptote. I guess the main thing that I want to focus on or draw your attention to is the thing in the green box here. The limit as x approaches positive and negative infinity for f of x would be equal to L, which is the horizontal asymptote. So, how does this show up? I mean, it's really just that connection to the graph and limits that we're focusing on today. I think I once told you that we're done with limits and not doing them anymore. I'm sorry I lied. But you'll see it's not very much. It's still the same type of thing going on. So if for this, actually let me give you a quick example of how this may show up. So if, for example, we have the limit as x approaches infinity and we had 1 over x. If I were to plug in infinity into there, 1 over infinity, infinity is just like, it's as it's approaching infinity, so do you see it's getting larger and larger and larger? So to understand the concept, I like to use things that are familiar to you. So instead of infinity, we could bring it down a little bit and just use a really big number. So we could use like 1,000,000, we could use 1,000, we could use 100. So basically we're just wanting to use a large number. So if I were to do 100 at the bottom, what would I get? 0.01, right? If I did 1 over 1,000, what would we get? 0.001. If I did 1 over, okay, we'll stop, but you get the point. As we make it larger and larger, what is this thing going to end up approaching? 0. Do we understand the concept? So this is what I'm trying to draw your attention to. If you have a situation like this where you have infinity in a denominator, it doesn't really matter what's in the numerator. Do you see that dividing by something, like dividing and having a numerator that or denominator that's so large means that you're going to basically get closer and closer to 0. We get the concept? So that's a nice strategy to use. If you're ever unsure because there's lots of stuff going on in the equation, you can always use a really large number. I mean, it doesn't even have to be that large, but like 100, 1,000, 10,000, whatever, to understand and think your way through the concept. So looking at this first example, if f of x equals 3x minus 1, blah, 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 find the horizontal asymptote. Okay, so we're going to do this using our new perspective and using this new method that we've just learned. So what I could say is that the limit as x approaches infinity of f of x equals, well, instead of x, I'm going to plug in infinity minus 1 all over 6 times infinity. Maybe I'll put it in brackets so you can see that that's the stuff that I'm plugging in, although I feel like that's looking really weird, but we get it? Okay. Do you see that if I have at the top, if I zoom in here, 3 times infinity minus 1, if I'm working with infinity, does the 1 even matter?
No.
Do you see that it's pretty insignificant? So I can just wipe it out and pretend it's not even there. So really, I have 3 infinity over 6 infinity. Oh boy, I'm having troubles drawing the infinity symbol. Do you see that those would just be gone because I have it both top and bottom? So after working our way through this, we just end up getting that the limit as x approaches infinity of f of x equals blah, 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 is equal to a half. So what is that saying? It's saying we have a horizontal asymptote at y equals a half. Yes?
Isn't the rule for horizontal asymptotes like the coefficient of the numerator and the coefficient of the denominator, like a fraction?
Excellent. So remember the rule from last year, I guess, was it last year or pre-calc 12 whenever you took it? So yes, that rule is there, but do you remember that we just sort of memorized a bunch of rules? So again, we're looking at the same old stuff, which kind of is what this whole course is. And that's why every single day I start off by saying, we're not doing anything new today. This is just review. But we look at it from a new perspective. Does that make sense? So we're looking at it from a calculus perspective. And know that it always leads to something else that we're going to be doing with it. So it's like a skill that we're developing. Good? Okay, find all the asymptotes of this thing. X plus 1 squared over x squared plus x minus 2. We want to do this, I guess, kind of using the same approach, but it said all the asymptotes. So let's start step number 1. Let's look for the vertical asymptote. X squared at the bottom. Oh, at the top you mean? Yeah, sorry. I moved it out of the way. I thought you were going to comment on my pink pen again, and I was going to kick you out. Okay, good. Because you got to get used to the hot pink pen or you're not welcome in this class. Good? Good. I'll balance it out. I'll use blue as well. Is everybody okay with that? Okay. So, again, drawing on past knowledge, what's the vertical asymptote, or how do I get the vertical asymptote? What do I do to find it? Thank you, Victoria. Look at the denominator, and basically we would take it plus x minus 2, and basically we don't want this to be equal to 0, so set it up however you like. I'm going to set it equal to 0 and we'll solve it, and then we'll look at what that tells us. Do you see that we can factor this? X plus 2, x minus 1 is equal to 0. So we would have a vertical asymptote at x equals negative 2 from right here, and at positive 1. We'd have 2 vertical asymptotes. So there's a part of it. So that's all old stuff. That's not really anything new that we've done. But then going on to step number 2, now we want to find the horizontal asymptotes, but we want to use our new calculus skills using limits. So we know when we're looking for asymptotes, we're looking for the limit as x approaches infinity. I gotta fix this. With our equation here. So x, that's not what I want. X plus 1 squared all over x squared plus x minus 2. See what I mean? Same old stuff, slightly different perspective. Are we good if I move all that stuff out of the way? Alrighty, let's focus on this. And so, we're going to go through some skills to make this easier for us to work with. For starters, I want to clean things up here a little bit. I want to get rid of the brackets and expand this out. So we know that this is like x squared plus 2x plus 1 when we distribute this, the x plus 1 times the x plus 1. And at the bottom we have x squared plus x minus 2. Okay, what we want to do, I'm just basically going through this to teach you this skill of things that we can do to make this easier for us to work with. We can multiply, we're going to multiply the top here by 1 over x squared. And I'm going to do this first, and I'm going to show you the reason in just a second. Over 1 over x squared. If you step back and look at the big picture, do you see that I'm just multiplying by the number 1? Because, maybe to help you to see it better, it's like I'm taking that and just dividing it by itself. So it's just a 1. So I haven't actually changed anything. I'm allowed to do it because I'm multiplying by the same thing, top and bottom. Good? And you're probably thinking, why on earth are we doing this? We're getting to that in just a minute here. So, I am going to run out of room, so I'm just going to continue down here. And I'm going to rewrite this. So x squared plus 2x plus 1, and know that I'm just doing this so you can see every single little step and where everything is coming from. So that's just me dealing with the top. I'm done with that part, the multiplying it out. And then I'm going to do the same thing at the bottom. I'm going to do, I guess, x squared plus x minus 2, but it would be all over x squared over x squared over x squared. There is no way that I expect you to actually write every single little thing out. I just do this so that it's crystal clear to you in your notes and when you're working on your own, what is going on and where it's coming from. Are we good so far? Probably still feeling like, what? Why is she doing this? Let's keep going, and then hopefully it's all going to come together at the end. So, working our way through this. Do you see for this first one here, it just ends up giving us a nice clean 1. Plus 2 over x, because I cancel out this x and this. Plus 1 over x squared. So far it's all good. Then when we get to the bottom, this also cancels out to give us a 1. Plus 1 over x. Because I have the x here and the x there, that cancels out. Minus 2 over x squared. Everybody good so far? I got lazy and didn't rewrite this, but do you see that we're looking for as x approaches infinity? So, I'm teaching you all the wrong things. You ready for this? This is the benefit of having technology. I'm so lazy, I don't want to write this all out again. Can I just stick in an infinity into here? Do you see that we're substituting in infinity into all of these? So far so good? Now when we think our way through this, if I have 2 over infinity, what is that? So I'm going to ignore the first part for a bit, but look at this second term at the top. If I have the number 2 and I divide that by infinity, what's that going to lead us to? We can say that's 0, right? It's wiped out. That's wiped out. That's wiped out. That's wiped out. Is that making sense? So, what we end up getting when we work our way through all of this, that would just be 1 over 1. So to clean it all up and to pull it all together at the end, the limit as x approaches infinity of that x plus 1 squared over minus 2, not plus 2, minus 2, is equal to 1. And why did we do that? Because we were looking for all of the asymptotes. So that tells me I have a horizontal asymptote at y equals 1. Does that make sense so far?
Why did we choose 1 over x squared?
Good question. Why did we choose way back here this 1 over x squared? As a strategy, here's what you want to look for. When you see something like this, you want to take the highest degree, and that's what we make the denominator out of. Why are we doing that? Because, do you see that that will allow us to get a whole number? And then for the others, it'll make it so that we're dividing by infinity always, which allows us to wipe out that part of the equation to give us 0, which is like a simplification strategy that we can use.
So if the leading term, instead of x squared, and say if it was like 3x squared, would you still use x squared or 3x squared on the fraction that you multiplied by?
Good question.
Would you always want to make it 1?
Yeah.
Okay. So then wouldn't you always
and or if we had x plus 2 at the top and we didn't have an x squared, then we could just multiply by 1 over x and at the bottom 1 over x.
Okay.
So look for the highest degree, and that's the thing that we want to multiply by in order to get rid of it.
Wouldn't that always make the